Hello, Algebra 2 students. I'm recording a video for you. Since I had to be out today, I wanted to make sure that your learning would continue. However, I did choose to make it a review lesson, so today we'll review graphing linear functions. Of course, when you hear the word linear or you see the word line, you know that we're really just reviewing graphing lines. So let's see what you remember from Algebra 1. Follow along with these notes and then you will have an assignment after. All right, I'm going to teach from the board now, so you may have to adjust the volume. But linear functions would come in one of two forms. Slope-intercept form is what I'm assuming we're all very familiar with, and that's our good friend y equals mx plus b. Remember, m is slope, right? Hence the very creative name, and b is intercept. Specifically, though, it is the y-intercept. So it will be where our line crosses the y-axis. Remember, on a graph, the x-axis, the y-axis is your vertical axis. So this will be where the line crosses the y-axis. That can be our, I like to say B is for begin. So that can be our beginning point when we go to graph. And then I say M is for move. So once we know where to begin, then we can move using the slope. That tells us the rate of change, or we measure that with rise over run. So very familiar stuff there. Standard form, maybe you don't see it written like this, but once you see examples, standard form is where we have the x's and the y's on the same side, and then equal to a constant c on the other side. So let's graph from slope-intercept form very quickly just to make sure we remember this good stuff. I already have y equals mx plus b form. So like I said, I'm going to begin with 4. That's our y-intercept. So I'll put a point there. Now I need to move to graph more points. The movement comes from our m. If it's a whole number, we can always put that as 3 over 1. And that tells us how much to rise and run. Now remember, just because I can't go up 3 over 1 on this particular graph doesn't mean that it can't be graphed. We can always go a different route. It's like when one road is closed and you have to reroute. So to get a positive line, I could go up 3 to the right 1. Or remember, you can also go down 3 and to the left. So if we continue that pattern of down 3, left 1, you can see how those points would still connect to make the same positively sloped line. This second example I just wanted to throw in because a lot of people sometimes make silly mistakes here. There is still a slope, right? There's that -1 coefficient in front of x, so our slope is -1 over 1. Now the plus b part is gone, so that just means we'll start at 0 or at the origin. So I'll start at 0, and now my slope is negative. So to make sure the line slants down, again, you can go one of two directions. I can go down 1 and to the right 1. You could also have gone up and then to the left. So you need to make one negative movement to get a negative line. So there's graphing from slope-intercept form. Remember, we did have some special cases. Some people often confuse the two here. A special case, instead of y equals mx plus b, where we usually have an x and a y variable, a special case would just be an x equals a constant or a y equals a constant. So those are going to be important to remember. We'll see them a lot coming up. Just remember, if there's x equals 3, that's saying x is always 3. So x is 3 here, but x is still 3 here and here, no matter what the y is. So no matter how far you go up or down, x is always 3. I kind of think about it, if it only has an x, it can only touch the x-axis. Okay, so this line is going to touch or cross through the x-axis. So on the flip side over here, y equals 3 can only touch the y-axis. So no matter what the x's are, you're going to always have a y value of positive 3. So you'll get this horizontal line. So those are our special cases. Just wanted to throw those in there. Now let's talk real quickly about what we'll mainly focus on, and that's converting from standard form. Remember I said maybe it looked weird how I wrote it, but this is an example of something written in standard form that you would need to convert to slope-intercept form. So before we would graph this, we would want to get it into y equals mx plus b form. So all we're doing is we're trying to solve for y. So I'm going to get y by itself. So it's just like when you draw a line and solve an equation, but this time you've got to really focus on which variable you're solving for. I'm trying to solve for y, so this 3x term can go away. So I want to subtract it, so 3x minus 3x cancels on both sides. So now I have the negative 2y, and then over here, remember we discussed last week, 8 minus 3x, those are not like terms. So we can't actually say that's 5 or anything crazy. What we do is we just write those as two separate terms, but we typically organize it in slope-intercept fashion. So the negative 3x first, and then the plus b or the plus 8 on the end. Now to solve for y again, I need to divide. So divide everything by negative 2 to cancel and get y equals mx plus b form. Notice that 3 over 2 is not going to divide evenly, but you do know that a negative divided by a negative is a positive, so now our slope is positive 3 over 2, so up 3 over 2, and then minus 4 as our y-intercept. So we can graph that starting down at negative 4 and then rising up 3 over 2. 1, 2, 3 over 2. Okay. So there is our line. We wouldn't graph that line from standard form. Instead, we would convert it into slope-intercept form and then graph after we have y equals mx plus b. So let's do these two. You can take a minute to pause the video and try if you'd like before, just to make sure you remember this good stuff from Algebra 1. My suggestion for the blue problem, not to make any silly mistakes, would be to put a 1 in front of this term, so we know that coefficient is 1. We just don't have to write it, it's assumed. So I have 3y. Again, not like terms, so I'll put the negative 1x plus 12, and then divide by 3. And of course, negative 1 divided by 3 will just stay a fraction. That's okay, right? Slope is maybe the one time that you actually desire a fraction. So that slope will tell you the rise over the run. So I can graph this one starting at positive 4. Notice it's a negative, so I'm going to go down 1 and then to the right 3. Your other option would have been up 1, but then left 3. So we need to have one negative movement to make that line slant down. Similarly, in this last example, I would put a negative 1 as my coefficient, and I'm solving for y. So I first need to move the x term. So take it away to move it to the other side. That leaves me with negative 1y equals negative 5x plus 5. And I'm not quite done because I just want y. So I need to divide still by negative 1. So y equals, a negative divided by a negative is positive. You can leave that as just 5 or 5 over 1 because, again, we like fractions there anyway. And then a negative 5 as our y-intercept. So here's our final equation in slope-intercept form. So we can graph the beginning at negative 5 and then count up 5 over 1, up 5 over 1. So that's a pretty big slope. 5 is a bigger number, so it makes the slope or the line steeper. All right, that was a quick little review for you of graphing linear functions. So now you will complete the Delta Math assignment to make sure that we're very good at this stuff in anticipation for tomorrow's new lesson where we will apply graphing linear functions.